Hello, everyone. Good morning and welcome to the Boston Plastic Recycling webinar series. Today's webinar will be um, concentrated in LCA modeling and system dynamics. Sorry for the small delay that we had some technical problems. So for the first part, and this is quite important, if you have any question, please write it down or raise your hand in the Teams application, and then we will let you speak in the attendees question part that it will be at the end. So in the agenda, we have just an opening and objective of the presentation as well of the webinar series. Then we will present the Primus project, afterward the TREASoURcE project, because this webinar is a cross-project collaboration among 2 European projects. So we will present the objectives of these 2 projects. Afterwards, we will start describing what's LCA and how it's done in TREASoURcE and in Primus project. Then we will have Alex explaining LCA linked to system dynamics. At the end, we will have some roundtable questions for both attendees and presenters to discuss a little bit. And afterwards, at the end, we will have the attendees questions. So if Julia, Kaisa, or Alex is presenting and you have any question, please write it down in the chat and we will let them know at the end of the webinar. Okay, so we will start here. So just to explain a little bit, this Boston Plastic Recycling webinar series, this is a series of webinars that are focusing on the latest updates and good practices of plastic recycling. So what we are pretending to do is to take out all the knowledge that we are creating inside the Primus project and other European projects and create webinars for interesting topics. So the Primus project, with close project among other R&D projects, will present innovations that are shaping the future of the circular economy. So today's objective is to understand a little bit more the LCA for circular economy projects and their application with system dynamics. So they will present, Alex and Julia, how they integrate the life cycle assessment with the system dynamics in the 2 European funded projects, TREASoURcE and Primus. So in the first part, Kaisa and I will present the TREASoURcE project as well as the Primus project. So I will present Kaisa first. Kaisa, welcome and thank you for being here. She's a communication coordinator and UE project at Click, and she has a strong background in planning and steering communication and dissemination efforts across diverse European R&D projects, with a keen focus on circular and bioeconomic initiatives. So thank you, Kaisa, for being here and welcome. And well, I'll present myself. I'm a senior innovation project manager at Mondragon Corporation. And well, in the Primus project, I lead the communication, dissemination, and exploitation. And well, I have a background in architecture, urbanism, and innovation project manager. And well, we'll start with Kaisa. So welcome, Kaisa, and please take the floor to explain the TREASoURcE project.
Thank you so much, Carolina. I hope you can see my first slide now. I was having some trouble with taking over the slideshow, but it should be fine now. So I know we only have 5 minutes, so let's dive right in. I will talk you about TREASoURcE. So as the project acronym implies, we truly believe that there is a treasure in resources. And this is why TREASoURcE's activities are targeted towards currently underutilized or non-circulating streams. We are targeting 3 key value chains, which are plastic waste, end-of-life electric vehicle batteries, and bio-based side and waste streams, which all have a huge potential that still remains untapped today. On this slide, you can see a few facts and figures about TREASoURCE. So it's a 4-year project receiving funding from the European Union under Horizon Europe framework program. We started in June 2022, so we will soon hit the midway mark with the project. TREASoURCE is coordinated by VTT Technical Research Center of Finland. And as you can see from the map, here our 16 partners are located in the Baltic Sea region. And what is special about TREASoURCE? It is part of the CCRI network. So the Circular Cities and Regions initiative has been launched and funded by the EU as part of the Circular Economy Action Plan. And what it does, it focuses on implementing the circular economy across Europe's cities and regions. And we actually have 7 cities and regions in total in the TREASoURCE consortium. So as a CCRI demonstration project, what we do, we develop, test, and validate different solutions that can be later on adopted and replicated by European cities and regions, knowing also that their sustainability has been duly assessed, as we will hear later today. Okay, this is a bit of a busy slide, but I wanted to show it to you anyhow. It reflects the work package structure of our project, but actually there are 2 important things that I would like to highlight on this slide. So the first one is the strong stakeholder engagement aspect, and the second one is the cross-sectoral and cross-value chain approach that we have in the project. So here you can see the 3 key value chains that we have in the project that I already mentioned in the start. And we are not only focusing on these 3 key value chains, on the development scale-up of technical solutions related to them, but we have a strong stakeholder engagement aspect that is very much present and transversal in the project. So this is integrated as part of the project, as well as part of these systemic circular economy solutions that we are developing. We engage with a broad range of stakeholders, and we co-create and we implement the solutions together with them. And second is this idea of cross-sectoral, cross-value chain approach. So what we do in TREASoURCE between the 3 key value chains, we actually exchange lots of information, lots of knowledge, and valuable lessons learned that we gain along the way. And this collaboration, this co-development across the typical sector lines and beyond also the usual suspects is actually something that is in the heart of the TREASoURCE approach. Talking about the concrete outputs of the project, we are already in the process of compiling together the results, methodologies, and data that we have gained in an interactive online tool, which is the TREASoURCE Replication Handbook. And the handbook will be an easy-to-use open access website where the user can easily filter and find content that is relevant to them, including concrete methods and guidance on how to implement these developed solutions. And on the right-hand side, you can see a snapshot of the website, which is already up and running, but it hasn't been published yet. So this actually brings me to my last slide for today. So next month, on the 29th of May, we will host a webinar to showcase the results and findings from the first half of the project. And also the replication handbook website will be launched at the event. So if you're in need of any supplementary information regarding TREASoURCE or this particular event, you can go to our website, treasures.eu, or if you want to register for the event right away, you can also use the QR code on this slide. But I think that's all from my side, so thank you for your attention.
Thank you, Kaisa. I will take back the control of the presentation. So thank you for the explanation, and it's quite interesting to see how you are going to approach the customers in the different key value chains. So we'll be looking forward as well for your webinar. Okay, so moving forward on the webinar agenda, I will be explaining the PRIMUS project. So the PRIMUS project is a European project that will improve the plastic recycling industry and create new products for automotive and home appliances applications. So we have 4 demo cases in this project, 2 for automotive and 2 for home appliances. So I will explain them a little bit afterwards. So the PRIMUS project is a European project that was funded in May 2022, and then we started the project in that time with a 3-year duration. So we are starting our 3rd year, our last year, and we are 12 partners located in different 6 European countries. So there you can see the different European partners that we have, and VTT is also coordinating this project, as well as TREASoURCE. So to see the objectives of PRIMUS, the main objective is to increase the sustainable use of recyclates with a high quality and safe quality and technical instructions that each of the products need. So we want to focus on creating new formulations for this plastics, recycled plastics, to be used in automotive and home appliances parts. But we are also focusing on traceability to increase the transparency of the plastic value chain as well as creating quality and safe recyclates through technological innovation. So we are using different recycling technologies to create these new formulations. We want to also support the use of recycled plastics as safe raw material with safe traceability, demonstrate the application on this 4 demo cases that I told you about in home appliances and automotive demo cases, and support the recyclate market with advanced mechanical recycling, debromination, because we need to take out the bromine of the waste, plastic waste residues that we are going to use, pre-treatment, and analytics. So the 4 of them cases that we have in our project is, the first one is an automotive interior that we are upgrading recycled PC and ABS formulation to respond to the aesthetics interior parts of the car using injection molding technology. The second automotive pilot is a cooling circuit, and we are upgrading recycled PP and EPDM to react together and create TP, it's a thermal elastomer vulcanized, and that will be suitable as well for the injection molding technology, and well, all the safe and technical requirements of both parts of the automotive interior and the cooling circuit. And for the home appliances demo cases, we have a third pilot that is a refrigerator to refrigerator inner liner to create the inner liner of the refrigerator, upgrading recycled heaps from different refrigerator liners, recycling them, and introducing them again with a food contact demonstrator of recycled plastics. And the fourth pilot is a washing machine door seal that we're upgrading recycled EPDM from the end-of-life cycle washing machine. So we are taking out, again, the seals of the washing machines to recycle them and to introduce them for new washing machine door seals. And as I have 5 minutes as well, we have two types of communities in our project. And if you are either industry or citizen and you are willing to know a little bit more on how to improve the plastic recycling, you can join us. You can access the webpage and add yourself to the industrial or citizen community if you want. And if you have any question about the project, let us know. So we will continue for the third part of the project and the main part of the webinar, that it's the LCAs and system dynamic link. So for this part, I will present the two speakers. Both of them work at GreenDelta. Julia Cilleruelo Palomero, she is a sustainability consultant and communication of GreenDelta. Welcome, Julia.
Thank you.
Thank you for being here. In the Primus project, she is the Sustainability Assessment Work Package Leader. She holds an integrated master in general engineering with a focus on the energy transition, and she started her own project startup on data sharing of LCA, and now works for GreenDelta for 3 years as a consultant helping private clients, but also reaching different R&D projects. As an example, Primus in this case. And our other speaker is Alexander Koch. He's a sustainability consultant and researcher at GreenDelta. In the TREASoURcE project, he coordinates the life cycle assessments. He has a master's degree in biological resources, where he focuses his research on sustainable forestry and the utilization of bio-based side streams. So welcome, Alex and Julia, and thank you for being here.
Thank you.
Maybe you can take control of the
Very
presentation.
Good.
Perfect.
Okay, so let's then go into LCA in TREASoURcE and Primus. The slide changed, right, Carolina?
Yes.
Very good. First of all, maybe for those that are not very used to the idea of life cycle assessment, it's something we do in order to get fact-based or we quantify sustainability with life cycle assessment. So it's a study that takes into account all life cycle stages of, let's say, a product from raw material extraction until end of life. That would be called cradle to grave. Maybe you've heard that. And then other life cycle assessments can also go from cradle to gate. So this would be looking at resources extraction until manufacturing and processing. So at plant would be cradle to gate. And it's been done since some time. So first studies already date to the late 60s. Coca-Cola prides itself for being one of the first ones to assess their sustainability with an LCA study. The study was mainly looking at, for example, energy uses and so. And then it has evolved a lot. It got a lot of attention since 1997 with the publication of the ISO standards, 14040 and 44. But the 14,000 series that help define a bit and standardize life cycle assessment. So how do we do life cycle assessment at GreenDelta? So Alex and I both work for GreenDelta, and we're working, I work on the Primus project and he works on TREASoURcE. We use OpenLCA software. It's a software that GreenDelta makes, okay, and it's a very widely used software in the world. It's an open source software for life cycle assessment, and it's also available for free. We believe it's the most widely used LCA software because it has such a low barrier, so anyone can just download it and start using it. So it's empty when you download it, right? So we need some data, and also we need some LCA methods, which will map our data into results. And as results, we will get life cycle assessment, okay, which looks at environmental impacts. But there's also some things called life cycle costing, which looks at economic sustainability, and also social life cycle assessment. And regarding the databases that we're using for these projects, it varies. But for Primus, we're working with EcoInvent and also environmental footprint database. But we're using environmental footprint database, which is a database proposed by the European Commission now in version 3.1, which is quite new. We use it a bit to benchmark, because this database, in order to use it and publish results, etc., you have to be doing a PEF study to use it for free, and we're not doing specifically a PEF study, so we use it to benchmark and to see, But we are in the first draft of this LCA studies for Primus, for the 4 cases that Carolina mentioned before. We use EcoInvent. EcoInvent, if you know LCA, you know EcoInvent. It's a very widely used database for life cycle assessment. It's quite proper in this regard. It gets updated every year, and it also covers the whole world and many sectors. So when you want to do an LCA study, it's a nice one database to use. And also, well, of course, I wanted to introduce a bit the Primo demo cases. So Carolina was calling them pilots, but basically here again, we are testing, the technologies developed in the project with these demo cases, and we are applying the LCAs directly in these demo cases, okay? Yes, and well, Carolina already explained it, so maybe I go forward. The aim generally is to improve the plastic recycling industry with new polymer recycling technologies, okay, for automotive and home appliances. So let's see how this is looking. However, first of all, we have to understand better what data to look, okay? In the end, we are comparing the use of primary material versus secondary material. We have to part from good LCA data sets, okay? But there is no time or availability to start from scratch. We don't have in the consortium of Primus, for example, partners that are producing primary plastics. When I speak about primary plastics, it's the same as virgin plastics, just that it was suggested to call them primary, and I agree. So yes, we don't have such partner that produces primary plastics, so we can't get primary data for those data sets, and therefore we have to look into what data sets we shall be using. So that was the first thing, looking for the data sets. We looked at different data sources for primary plastics, okay, starting from the beginning here, Plastics Europe and their eco profiles. These data sets, let's say they're cradle to gate, okay? We get them until we're interested from the start of the supply chain until when they're produced and they're in their factory. So in that sense, Plastics Europe has really nice data. I wanted to see where the data quality was best in. I also wanted to understand what data, what life cycle stages were taken into account, and what the system boundaries were, really to understand how they achieved results. Because in LCA, you can get some results, but it's very important to understand what are the assumptions and how the LCA study looks like in order to understand what the results are, right? So I wasn't happy to only have I have a data set for a specific plastic. I also want to know what is this data set, right? So the conclusion here is Plastics Europe has the best documentation, okay? It's really, really well documented. They collect data directly from plastic producers. They have a really high percentage representativeness, so very good, okay? Their reports are really good, really technical, and in comparison to the rest, but generally, I thought. And then also It's third-party verified. And it is such that other databases actually use these eco profiles in their own databases. Eco profiles are available for free in Plastics Europe. The only disadvantage is that a lot of them are quite outdated. So the data was collected quite some time ago, sometimes even more than 10 years ago. And so one has to use this with a pinch of salt. And then a bit of my findings looking at in depth about these data sets in these databases. CarbonMinds is a new database that comes up because of the need of chemical data sets for life cycle assessment. It is so that it was hard to track how the data set came to be there. Hard to track what was the original data collection, what was the processing done afterwards. The data sets are also intransparent. You don't see, it protects, let's say, the information. So I only see the results, but not understand what makes the results and so. But generally, the only one that's not intransparent is EcoInvents that uses unit processes. And sometimes even due to data protection, it also protects it. And Federal LCA Commons is the database from the US. Generally, we went for EcoInvent because EcoInvent bases its data sets on Plastics Europe mostly, and had a nice documentation in comparison, for example, to other databases. And so, what about secondary plastics? So there's not that much data of secondary plastics in comparison to primary plastics. So we are benchmarking what we're calculating and our data collection with environmental footprint database, which has some recycled data sets. Okay, so we are making our own secondary plastic data sets for Primus projects. These are called eco profiles. And so, yeah, this is more that we make it instead of that that we need to gather it, but still it's nice to see benchmarks of how other data sets look like. An eco profile is something that we aim to produce with a Primus project. It's an LCA data set that aims to represent an average production cradle to gate of, in our case, a certain recycled plastic granulate. The data collection has been done by Plastic Recyclers Europe, which is a partner of the Primus project. And yeah, the first draft of the data, it doesn't look amazing, let's say. It's hard to collect data, as everyone knows from LCA, but this is transparently what we have currently. There's quite some gaps found, probably underrepresentative data. We aim to improve quality, and we're working with Plastic Recyclers Europe to do so. But the representative right now is a bit more than 8.5% for recycled PET, for example, but very low, less than 3% for recycled HDPE. So it's a nice thing, the eco profiles, but of course they are more useful if a representative amount of recyclers are represented. So we're working on that. And the life cycle stages that are involved are collection and sorting, size reduction, washing, density separation, and extrusion. The covered plastics will be PP, PE, PET, PS, ABS, PO, LDPE, HDPE, and coming from a different, from household, WEEE and industrial. We also aim to regionalize these data sets too. So in the end, we will have, the aim of the Primus project is to come up with 50 eco profiles at the end. And it will be summarized in a 3-page document, like a short document. We, of course, want to be transparent about how we came up with this data. It's very important for the LCA community to do so. And therefore, we have, yes, background information, how a bit the model description, what was used, and the system boundaries, etc. And then some model results, not just generally the results, which would be here, but also a bit what the average, for example, electricity intake is, and so forth, that is useful also for other LCA practitioners. So how does then the demo case results look like? We have, I'm going to show you a couple. Yes, and this is very focused on the Primus project. The next part will be more on the TREASoURcE project. So what came out of our initial assessment then? So using Equinvent and also using the EF 3.1 LCIA methodology, meaning yeah, it's a proposed method from the European Commission that also has single score. There's 4 scenarios that are considered. Base case, where all primary, well, the base case is the normal one, everything's primary material. Then we have version 105, where everything's changed to post-industrial. By the way, this part is completely made of PC and ABS only, no additives. So when we change to everything post-industrial, that means 100% of inputs are from, let's say, recycled. We also changed to 75% post-industrial, and also we have a demo 1 which uses post-consumer instead of post-industrial. And here we can see the graphs. So in this graph, we see all of the impact categories together. It's something called single score, where we normalize and then weigh all of the impact categories so that they're under the same scale. The point here is so that we see the improvements of all of the impact categories in one graph. So not only we would look at, and there's an improvement in climate change, let's say, but we see an overall improvement in all of the impact categories, which is nice. These are really good results. Generally, we can see definitely that there's a lot of improvements to make everything recycled. Okay, we see that, you know, this is 100% recycled from post-industrial versus 75%, and so on. Generally, let me say, yes, post-industrial looks good, but it's not the aim. The aim is post-consumer, okay? Because, of course, it's nice to recirculate and bring back to the economy scrap from factories. That's post-industrial. But it's very important. In the end, we produce a lot of waste. You know, you are in your house and you understand how much waste you produce. It would be nice to have, generally in circular economy, to have as much as that waste being brought back to the economy. And therefore, that's post-consumer. And that's what we aim for. And currently, yes, the current talks are about if we should consider post-industrial as recycled material and so forth. So generally, we would aim for post-consumer, for your information. And then the second demo that I wanted to show you, so that to be transparent that not everything's amazing. We have here the demo 2 looks at a tube car coolant, which is made of polypropylene, but also EPDM and additives. Okay, the additives are 29%. And then the recycled case has, out of the 100% of the formulation, 23% comes from recycled material. Why only 23%? Because more than 23% influences the material properties of the formulation of, you know, yeah, the polymer, and it cannot be used any longer for tubes for car coolant. Okay, so this is the maximum that was achieved to respect safety boundaries of material properties. And so we assessed then with this, how much was the improvement. And here you can see that there wasn't that much improvement. That, yeah, 23% is nice. It's cute. Maybe it helps you doing some greenwashing in your marketing campaign, but it's not making a lot of a difference. Let's see then what's next, because here we look at LCA. LCA is a narrow thing. I'm looking at what's in comparison, what primary scenario is with recycled scenarios. But what about the whole picture? How does my change in my product influences sustainability as a whole, right? So what's the whole picture? So, for example, what about microplastics? Microplastics are not in my LCA studies. They're not in LCA generally. We should take them into account if microplastics are a danger for the future and is something that's probably happening in our technologies. So this is something that we're going to look into. Also, what about sustainability in the context of the system we live in? So yes, so for example, social acceptance is something we look into Primus a lot in the work package 6 for sustainability. Because if society is not prepared to accept products with recyclates because they think they're not safe or something like that, then there's no point in making them. Maybe we have to prepare the audience first before we introduce these type of products. Or is this enough? The last point, is this enough to reach the sustainable development goals? Is this going to alleviate resource extraction? Is this going to alleviate climate change or so? So this is the next step. It's something that we want to integrate with what Alex will now speak about, system dynamics, which looks at a more bigger picture of this. So we part from LCA, which is a tool that's very strong and that has helped us a lot. And we want to go a step further. Thank you,
Julia. Now, thank you for the LCA explanation and how it was accomplished and tackled in the Primus project. Now Alex is going to present the TREASoURcE part as well as the system dynamics link. So can you take the control, Alex, please? Good, perfect. You are muted.
Yep, I'm muted. Okay, now
Good,
you can
perfect.
hear me.
Yes, we can.
So yeah, I will basically make a bit of a transition from LCA and have a more focus on actually system dynamics and how we can conduct sustainability assessments with system dynamics. And this is closely linked to the TREASoURcE project and how we are proceeding with the sustainability assessments within the TREASoURcE project. And I will explain this a bit throughout my presentation. But first, I want to kind of go to the beginning and take a step back and maybe even think about the definition of sustainability or sustainable development, which many usually refer to the Brundtland Commission's definition as meeting the needs of the present without compromising the ability of future generations to meet their own needs. And when we really think about this definition, it really tells us that sustainability is about a system that can reach certain boundaries or thresholds where we change the system in such a way that causes irreversible changes, and these changes basically disallow future generations to meet their needs the same way we did meet our needs. And so essentially, sustainability can be about a very dynamic system that needs to be maintained, and that means not exceeding certain boundaries. And when we think about the planetary boundaries, which I have shown here, or which I'm showing here, we have already somehow defined a safe operating space for several categories, and measuring basically our impacts within those categories, we see that a lot of these limits, these thresholds, have already been surpassed and are basically now already causing irreversible changes. So if we think about sustainable development in terms of the planetary boundaries, we're not sustainable at all. And this is often kind of forgotten when we're doing our impact or when we're doing our sustainability assessments. What we also need to think about is that sustainability refers to a multidimensional system. It's not only about the environmental impacts, but also about the social economic aspects, but of course also resource use, the market condition, the context we live in. So there's a lot of different dimensions that kind of interact and are kind of intertwined, and we need to think about these interlinks. But like I said, or how Julia also presented it, nowadays a very good tool actually of that we use to measure impacts, environmental impacts, social impacts, economic impacts, is using these life cycle tools. So that we have life cycle assessment, life cycle costing, social life cycle assessment, and often we kind of think of sustainability assessments as basically the sum of these three dimensions. But these kind of tools have a few limitations. So for one, like I already mentioned in the previous slides, we don't really consider the threshold. So what is my impact within planetary boundaries, for example, within certain limitations? We also often, like Julia also kind of showed, we often just look at it in relative sense. We say that one product might be better than the other, but we do not consider whether that impact that we've just measured is actually within our limits. Another limitation is that we don't look at the relationship between those different dimensions. We don't think about burden transfers. We might have a burden transfer from, a positive development in one dimension might lead to a negative development in another dimension or impact category. So we assume a very linear causation, or we have a linear causal assumption. Furthermore, we often don't consider the context. So in which region we're actually measuring this impact. For which region is the life cycle, in which region is the life cycle taking place? And when we're doing certain recommendations, to improve certain impacts, are we considering, the market context? Are we considering the regional conditions? Are we considering the resources that are available within certain regions where we want to, implement sustainability strategies that we come up with when, conducting these life cycle studies? Often this is not considered. And lastly, it is a quite static approach. So we're not really considering the element of times. We're not doing a dynamic assessment where we're really just looking at one moment of time and not considering how the different elements of a life cycle assessment might change over time, or might change when you're upscaling a technology. So often this prospective modeling approach is missing. And in the end, this kind of leads to recommendations that are quite limited in terms of its feasibility for specific regions, for example, but also in terms of the replicability. So not being able to transfer certain solutions from one region to another, for example. So in the end, we have a few opportunities here also, is that, sustainability assessments in essence require, a context-based sustainability assessment where we really look at, for example, our thresholds, our planetary boundaries, and we can see then, are we within our safe operating space, or have we gone beyond this safe operating space and need to kind of go back in order to prevent from any kind of irreversible changes from happening? Furthermore, life cycle or a product system is part of a very multidimensional system, which for one, in terms of the sustainability dimensions, is closely intertwined, but also when considering the spatial temporal context. So what is the market that we're actually introducing our product in? Is this actually feasible for that market? What impacts will, introducing new products or an improved product have on certain dynamics of other markets? So in the end, considering these aspects will allow for more localized and dynamic decision making, where you essentially also consider the trade-offs, because we do not only we're not looking very one-dimensional, but we're looking at the different viewpoints and different links that are linked to the life cycle we're studying. And this is essentially more inclusive for one. It can be more effective when you're applying certain strategies, and these strategies essentially can be very feasible to the context in which you do apply this. And this is where we kind of came up with, what is a method that we can use to maybe conduct sustainability assessments with considering these like limitations of life cycle assessment. And that's where system dynamics comes in, where we can basically model an entire system dynamically. So the idea is that we model systems as a combination of stocks and flows, and those flow rates, will change based on factors that you define to be your external environment. And the dynamic the approach allows us to do a dynamic assessment because we do simulate basically the development of stocks over time and the development of rates and stocks and basically also external factors over time. The advantage is that with system dynamics is very flexible and we can really model any kind of system, and the scope and level of detail is totally up to the modeler. So it really gave us the opportunity to basically also model a sustainability assessment model within a system dynamics software. And here it's just a brief an example shown on this slide is basically we have a population of rabbits and a population of wolves that is closely linked to each other, as a dense population of wolves might have an effect on the population of rabbit, the death rate of rabbits, and there are different factors that also come into play, such as the area, such as the density of each population, how close they are to each other, and with defining these kind of birth rates, death rates, and the external factors, we can simulate, and this is shown on the right, the population of each of these animals, so the predator and the prey over time, and this is a dynamic basically approach, so we can also kind of define changing factors or changing quantities or measurements for the different elements of the model over time, which is quite nice. And in relation to sustainability assessments, when we're thinking about this modeling approach, it really allows us to, for one, include boundaries, allows us to conduct dynamic modeling over time, and also consider, this multidimensional and interlinked aspects of a system, of a sustainability assessment approach that really looks at all the different dimensions and all the different basically elements of a model that need to be considered. And in the TREASoURcE project, we kind of developed a system dynamics model within a system dynamics software called Stella. And we really try to kind of consider the application that we have in the TREASoURcE project. So we're looking at different regions in which we want to apply certain circular economy strategies for the 3 value chains. So for plastics, for biomass, and for batteries, and consider what are the different dimensions or the different indicators that we need to consider when we're applying certain sort of circular economy strategies. For example, introducing new recycling technologies for a specific region, for plastics, for example. And what we came up with is that, there's, especially when we're considering the regional context, so when we're putting the value chain, the life cycle into context and thinking about all the different basically elements, external factors that would influence the rate of change of the stocks within that life cycle, within that value chain, we especially came up with that the market is a very driving element, of course, and the local market will basically determine the amount of stocks, essentially. But we also needed to kind of consider, the context indicators. Are consumers within that region willing to go for higher, or prefer or appreciate, the higher amount of recycled products being on the market? Are they willing to actually purchase those? Do we have enough, or a good enough infrastructure on site in the region that allows for a higher, capacity of recycling technology. So allowing for higher recycling rates. Is that even possible within that infrastructure? And these are a couple of examples that we kind of tried to integrate. And then, of course, in essence, this is a sustainability assessment tool. So we want to measure the impact of changes within that region, of the changes we make when we're introducing new circular economy strategies or technologies. And so we're measuring the social impact, the environmental impact, the costs, but also the resource use. And this can be seen, as the outside elements of the model. In the center, we have the core value chain of the life cycle of certain products, and we're looking at multiple products here. So not just one product, but we're looking at, for example, in the plastics case, all the different types of plastics within that region that flow through each value chain stage or life cycle stage. And then, of course, we have the market, which really drives the production, the sale of those products. And in essence, what we try to basically then figure out is what strategies will allow for higher circularity in that region and will allow for better recycling rates, or the industry being more interested in driving the demand for recycled products. And this model was then applied to a specific case. So we looked at one of the regions that we're looking at in the TREASoURcE project, which is Fredrikstad in Norway. And we basically collected data on the material flows for different polymers or plastics within that region. And then we collected the data for the environmental impacts and the market, as well as the recycling rates, the local recycling capacity that is available now, and kind of then with that kind of looked at different. So, and this is basically what the tool is then able to do, is you're able to kind of conduct a scenario analysis where we basically try out different circular economy strategies and figure out which strategy is most suitable for the region for one, but also would lead to the best results or impacts. This graph just shows basically the development of the products offered stock. So really the plastic products offered on the market within that region over time, and we simulated over 45 years, and we kind of found out that especially for the LDPE, we have at one point, because the price development that we're also kind of modeling within the system dynamics model has a strong decline, which increases the demand for this product, leads to basically just a market collapse because the resources run out. And this is where we can really see that, because we've integrated basically also the planetary boundaries and the resources available for these different products and the different markets or sectors. And this basically then shows us that after 30 years within the business as usual scenario, we're already running out of resources for a specific sector. And this leads us to think about, okay, what strategies can we implement in order to prevent that from happening and prevent us from reaching this kind of limit. And then we tried out different, of course, recycling capacities, introducing, minimal recycling rates for the industry. Also, kind of improve technological developments of the sorting within the recycling value chain, but also the recycling, and also introducing market incentives that pushes kind of for the demand of recycled products. And with that, we could really this is basically a graph that kind of shows the environmental impact climate change for the entire, the entire basically plastic value chain that we're looking. So all the different types of products and materials with it that are using plastics for that region, and we can see that introducing these strategies are for one feasible for that region to a certain extent, because you have certain capacity limitations, of course, but kind of result in a lower accumulation of environmental impacts. And I'm not showing this here, but also this leads to, having operating basically these production volumes within the planetary boundaries of the resource use that I've shown earlier. And this just also to mention this, the environmental impacts for these different life cycle stages within that system dynamics model is a perspective. So we're really looking at how the environmental impact changes over time, and basically changing that impact within the system dynamics model. But this is also, of course, the main link now to LCA. So we are still using life cycle assessment and OpenLCA as our life cycle assessment tool in order to calculate environmental impacts and then transfer this into the system dynamics model. And this is the main link between the two tools at the moment. System dynamics is not being used to kind of calculate environmental impact factors, for example, but is more kind of used to kind of model the entire system and see how different elements of the system change over time, and how this can be more system-based or intertwined in a way that allows us to see how, especially the volumes of the product life cycle changes over time due to market conditions, due to the context, due to certain policies being introduced. And when you take these volumes and then recalculate your emissions at each time step, this really allows us to link the two tools together quite well and say that, okay, we know how the local conditions are, we know how the quantities change for each life cycle step, and then with life cycle assessment we know the environmental impact factor, for example, that we can then use to calculate the total impact for a specific region. But just to summarize here, so for one, it is now possible kind of with this to do a dynamic or a prospective analysis and really simulate changes over time. We're able to set also boundaries, look at resource availability, or when we're looking at the context, really recycling capacities. We're able to do a scenario analysis and kind of test different strategies, and this especially allows or supports the decision-making processes for different stakeholders. And for the TREASoURcE project, it is especially relevant because we're looking at regions. We're working together with a lot of municipalities and cities, and this allows us to really look at the region, the context. So what are the available material flows within that region? What are the waste management capacities? What does the market demand look like? And with that, we can really kind of make more, or introduce more feasible recommendations when conducting a sustainability assessment. Yeah, that's my part of the webinar. Thank you.
Thank you, Alex. I will take control of the presentation. So thank you for explaining us what the system dynamic model is and how it's interlinked with the LCAs and how it is approaching the TREASoURcE project. I think this is quite interesting. We will move forward to the roundtable questions. The first question that we have for both speakers, and maybe Julia, you can, yeah. turn on your camera and microphone as well. The main idea is that you both could share your experiences in both projects in these 3 questions that we have prepared, and we have some questions from the audience as well that we will answer afterwards. So just remember that for all the people that are connected, if you have any question, write it down in the chat or in the PR&R section, and we will answer all the questions at the end of the webinar after the roundtable questions. So the first question is, what are the advantages and constraints of this link between LCA and system dynamics?
Maybe, Alex, it's a good idea to briefly explain how we're linking them also.
Yeah, I tried to kind of do that at the end, but the main idea is to kind of have a lifecycle assessment tool that kind of is using kind of parameters where the system dynamics model delivers data to the LCA tool for those parameters as you progress within the simulation, where you go, at each time step, you are changing, those parameters change over time, and those parameter changes are then sent to maybe the LCA tool, and this is how I'm kind of imagining it right now. And the LCA tool then recalculates the impacts with these changing parameters, and that impact is then also sent back to the system dynamics model, where it then kind of has that environmental impact factor, for example, updated. This is how I imagine it right now, but this is maybe not so defined or not so clear yet.
Yes, and currently, so that's maybe the goal, to have such an automated link. Currently, we actually do it the opposite way. We get LCA results and put it into our system dynamics model.
Okay.
So, well, I mean, Alex can add on what I'll say, but the advantage directly is to put in context the LCA results in the context of the world we live in. So Alex spoke about a smaller ecosystem of a local region, but for Primus, we will be speaking about plastic supply chains and just generally the plastic picture. The advantage already is that, for example, we will see littering, where littering happens, where microplastics happen. I mean, it's linked around the system dynamics model, which is something that we don't get currently with LCA.
Okay, so this is a work in progress, and hopefully we could have an example in both projects at the end. Then moving forward to the second question, how qualitative and quantitative aspects are related with system dynamics? What biases may it have?
Yeah, so the like initial idea with this approach was that we make a tool where you can do also qualitative assessment. So not having, because this is usually the main bottleneck and limitation when you're conducting these sustainability assessment studies, is that you take a very long time to collect your data for your product life cycle. And the idea was to kind of come up with a model, also a qualitative model, where you can really make qualitative, maybe expert-based assumptions, enter that within a model that is actually been validated, and where you can really just calculate quite quickly some kind of scenarios that allows you to then make quick decisions for certain life cycles or strategies that you want to implement for certain products. And right now it kind of went more into into a direction where we have a model that we need quite a lot of quantitative data, but the idea is to still be able to define certain let's say, scenario sets or certain elements of the model that can be, for which qualitative assumptions can be made within a certain range that is kind of representable to the real world conditions. And of course, those assumptions will be very, uncertain, maybe. So it's kind of linked to maybe a validation step where we kind of validate the structure of the model, check whether, the results that we then simulate with those assumptions kind of follow the historical trends, for example. So kind of link this with validation steps in order to give that qualitative assessment a bit more of a backup somehow, that it actually is the way the development is expected to be.
Yeah, because you were when you showed the TREASoURcE map, you showed like the market and legislation and social aspects. So for a social LCA, I guess that this kind of qualitative aspect is taken into account, as well as how the consumers are approaching the recyclates, for instance, that and how they and the legislation, how it's approaching this recyclates as well in Europe. So I guess this will be part of the system dynamics models as well.
Yes, definitely. And it's quite a big model right now, and like this is maybe one of also the constraints, is that we need a lot of data. Right now it's quite data heavy, and we need to kind of find now a few strategies in order to reduce that somehow. And one approach is, this scenario development, where we're just looking at different elements of the model and saying, okay, data collection for this element is really not possible, so we're just going to define some scenarios or do some assumptions, and then be able to also back up those scenarios with some kind of validation, which is not clearly defined yet, but this is our idea at the moment.
Quite interesting. Thank you. Hopefully, we will see the final result of the model. And as a third question, it is recommended to incorporate feedback loops between empirical findings and the structure of the model.
Yeah, so it's for the TREASoURcE project it's quite interesting, because we're looking at three very different, or not very different, but quite different supply chains or value chains. We're looking at bio-based silent waste streams and how we can use this for biogas and biofertilizer production. We're looking at batteries, second life batteries that can be used in energy storage coming from electric vehicles, and we're looking at plastic recycling, especially mechanical and chemical recycling. And for each of these value chains, we have a very different circular structure. So one is recycling, one is reuse, and one is regeneration of bio-based silent waste streams. And the structure of that value chain is therefore quite different. And we initially thought, okay, we're going to make a system dynamics model that can be applied to all the different cases. But quickly we found out, okay, there's so many things that we're not thinking about, when we're making a theoretical or theory-based model, when we're applying it to a specific case. And we kind of needed to make some changes within the structure, as for the structure of the system dynamics model, based on our findings when we're really looking at the different value chains. So in the end, part of this framework of applying this as a sustainability assessment will be basically trying to change the structure, or having to change the structure of the model before we kind of make our calculations. So that is really integrated within, or needs to be integrated within the framework.
That, I guess, Julia, is the same case of having different feedback loops in an LCA.
Exactly. And generally it's an iterative process also. So we learn from our findings, we can adjust and then continue.
But
So
I guess,
it's
yeah, it's very, I mean, our also framework is very inspired by the framework that you use when you're conducting life cycle assessments. You know, this starting with goal and scope, collecting your data, doing your assessment, then doing the recommendations. These are kind of the steps that we also take with the system dynamics model, with a few new steps. But of course, like in LCA, you know, it's iterative. So you know, once you've reached certain stages, you might need to go back to initial stages and change your goal or change the scope of your study based on, you know, data gaps that you might come across.
Yeah,
So
for
it's
sure.
quite inspired by also, yeah, the framework that is applied by LCA.
Okay, thank you both. We have a question, and I will share my screen right now because I wrote it down in the presentation that we have. But this question from the audience is for Julia. For the EF 3.1 database used in the LCA project, it is a free download database for OpenLCA. And when you choose the best suitable database to work with, what is the main requirement for data quality for the Primus project?
Yes, I can start with the first one. So the EF 3.1 database is a database offered for free by the European Commission. You can find it in the European Commission Lifecycle Assessment Data Point. Okay, it's a website where you have different nodes, different actors give data to this database. Okay, so you have Sfera giving some data, Equivent giving some data, Quantis even giving some data, different actors giving data, etc. This data is in a format called ILCD format, and it's there. You can download, you can, well, use it somehow. We get this and we put it into a database called the EF 3.1 database for OpenLCA. Okay, so yes, it's available to download in Nexus. It's a free database, but you have to have something called the database analyzer and launcher, okay, which has a cost. This helps us finance the work done to make this database available for OpenLCA, because a lot had to be done in order to make the data coherent all in one database and also available in the data format for OpenLCA. So yes, if you look for EF 3.1 Nexus, because Nexus is the data market for data for OpenLCA, you'll find it there. So that's the first one.
Okay.
When you choose the best suitable database to work with, what is the main requirement for data quality for the Primus project? So with data and LCA, you don't go very, how do you say, sophisticated, let's say. You want the data to be from a, let's say, reliable source. You want it to be up to date. You want it to be representing what it has to represent, so that it represents the right technology with the correct or a good representative collected data in order to then model the data set. And so that is what we go for. There's not that many options, and from there we get what is best suited. So we in the end chose Equivent because the data sets were those of Plastics Europe, which are the best quality out of all, except for the fact that they're outdated. And then they're integrated into the Equivent database, which is anyhow the database we're using for the first draft of the LCA studies. So then it's easiest for us to have data sets integrated into the database we're already using. And that's how then we chose the suitable data set and data sets to work with. If you choose it, depending on the database you choose, depending on the data sets you choose, you'll have different results. So then it's really important, depending on the LCA method you choose, you have different results. So it's very important then to look into what you're using, yes? specifically because we're comparing recycled versus primary options.
Thank you, Julia, for your answer. As I'm sharing, I don't know if we have any further question, but I really have a question for you, Julia, as you are part of the PRIMUS project. In the traceability system that we are using, the digital product passport, we want to integrate the LCA with system dynamics. So my question is, how system dynamics will work with the digital product passport, or it will as it will be linked with the information of what's happening in that day. Will the digital product passport information will change, or is just one time stamp and then it will change when you create a new product, for instance?
Very interesting question. So I can bluntly say that it's gonna be two separate things. So system dynamics will not be integrated into the digital product passport.
Okay.
However, maybe digital product passport information can be used to fit into the system dynamics model. So maybe to just reiterate what Carolina was saying, we are in the Primus project working in a really interesting case for LCA, which is there's a startup called Cilleruelo that has a blockchain system for traceability of supply chain, which has the potential to communicate data across the supply chain that's secure because it's blockchain and so on. And so yes, we are collaborating with them in order to integrate LCA or LCA data into their system. And currently, the first step is to communicate basic LCA results in the product passport. Okay, so in this case, you will only see results of your specific life cycle stage in the supply chain, with also transparency of how these results were calculated. So system boundaries, database, method, and so on. Ideally, we find a way to expand this to communicate data, actually, LCI, inventory data instead of results, in a secure way. That's, for me, would be the aim. But we're doing it in this first stage like that. But yeah, system dynamics is not currently going to be integrated into this supply chain traceability.
Okay, perfect. Thank you for answering this question. We still have another question, I think. Yes, in the chat. Have you considered use of AI to build links from LCA data to ESD modeling? And I guess this is for Alex.
Yeah, it's been something that we're maybe thinking about, but at the moment we haven't really tried anything with that. I mean, it's of course maybe an option for this scenario development, or this somehow generating some kind of data that allows us to deliver data for a lot of the data gaps that we have with a data heavy system dynamics model. Also with considering the changes over time that you have when you do have constant changes, and it's really hard to really update your data frequently, because data collection usually is quite of a time consuming task, and maybe AI somehow could be a supporting tool in order to kind of allow for a more dynamic and timely assessment or data delivery.
Maybe we could seek for another European project.
I think also AI feeds or learns from a lot of data, right? And the point is that in LCA, we don't have that much available LCA data as such for an AI to really become strong and useful. But there is a lot of data out there. So maybe building on already existing AIs also for example, system dynamics well, it's something that we it would be nice to look into, but it would have to be a specific focus, no, and a specific task. So yes, as Carolina said, maybe a good thing to think about, yeah, and consider for future research.
That would be interesting. Okay, guys, I think we don't have other questions, so we can start closing our webinar. So thank you for being here. This is a recorded webinar, so we will be sharing this webinar in our YouTube channel, Primus webpage, LinkedIn, as well as TREASoURce's social media channels. So if you are willing to learn a little bit more, please join us, follow us, and we will be creating more webinar series with other European projects, as well as TREASuRce's social media, that they have really interesting webinars as well as results. So thank you all, and thank you, Kaisa, Julia, and Alex, for being here.